Hello and welcome to the fourth and final episode in Unit 1. This episode will be on casting and errors. So, the preliminary concept before you can understand what an error is a compiler. And a compiler is a program that converts code into binary that the computer can read. So, this becomes important in a compile time error, right? A compile time error or a syntax error is an error that occurs when trying to compile the code into ones and zeros because the compiler cannot read the code properly and therefore cannot convert it into the correct sequence of ones and zeros. Then we have the runtime error, which is an error that occurs if there are no syntax or compile time errors, and it's caused by basically just illegal statements, and you'll see what I mean in a second. And then there's a variation of runtime errors called exceptions. And exceptions are perfectly legal statements. They even would pass through like the runtime errors, right? So they're completely legal, yet the programming language just doesn't allow it, right? So this would be your dividing by zero. It's an exception because the programming language just doesn't allow that code to run. And then there's a fourth type of error, and this is my personal favorite. It's when you think you're doing everything correctly, you write your code for a week, right? And then you get this one error, and it turns into two errors, and it turns into three errors, right? And this is a big oopsie. That is how you will refer to it officially from now on. It's a big oopsie. So now it's time for examples of these errors, right? So the first error here is your syntax error, right? So if you just spout out a jarble of words, then the compiler cannot read it and therefore cannot do its job, converting it into binary. And when we run this, you'll see, oh, compile time error, right? So right here, big issue, right? No good. You did bad. Now, I did this on purpose here. You'll see that, oh no, system.out.println 3 divided by 2. What's going on, right? So it was expecting sorry. So it was expecting a semicolon at the end of this, right? And this is just one other way that you can get a syntax error, and it's if you don't add a semicolon. So if I were to write system.out.println 3, and then I just don't add the semicolon, boom, big error, right? So those are your main ways. Either you just misspell stuff, you type in random garbage, or you forget a semicolon. The other type of error here is your runtime error. So look at this example. This code is written perfectly fine, yet it'll give us an error. Why? Well, the big answer here is that an integer can store only about this many values, while the number we're trying to store is this big. And this causes an error because it's just illegal. It's an illegal statement. And you see, we get an error on this. And then here's our exception. Right? The only exception you need to know for this unit is the arithmetic exception, and this is when you divide by zero. Again, right, this is giving me another error. That's for later in the video. My bad, guys. But here you'll see, oh yeah, arithmetic exception is thrown because we're trying to do 0 divided by 0. Okay? And this is completely not allowed in Java programming language. Now, let me show you a little bit about casting. So typecasting is a method used to convert variable values or just any value from one type to another, right? So we have all of our primitive types listed here, and they're listed from the least amount of memory to the most amount of memory. So for this case, we're going to be ignoring char because casting with it is kind of weird, right? So these four values here all store whole numbers, and then these two values store decimal places. And one important thing to touch on here is that the float and the double are required to have decimal places. So you can't store a number like 3, it'll always become 3.0. But carrying on to casting, when it comes to converting the type from one to another, or just casting, that's the word, casting, you always want to move right up this hierarchy, right? So you want to move from less memory to more memory. The reason why we do that is if you have an integer, for example here, right, that can store a value of like 3 million, right, while a short can only store a value of 65,000. If I have a value of 3 million as my value and I want to change it to type short, then I'm just not going to be able to, or it's going to lose precision because we can only store values up to 65,000. And it's time for examples because this doesn't really make sense without examples. So in this first one, we have this thing which is basically printing out the value of the expression 3 divided by 2, okay? So it's an integer divided by an integer, right? And since they're both the same type, then the output will also be that type, right? So 3 divided by 2 should give us a value of 1.5. But as we said, doubles and floats are the only ways for us to store integer value, to store decimal values, right? So when we return the integer value of 1.5, oh, come on, I wanted to comment this out, I'm sorry, guys. So when we are given the integer value of 1.5, you'll see that just gives us a 1, right? So 3 divided by 2 gives us a 1. Now let me tell you why. So this gives you the value of 1.5, right? We have an integer divided by an integer, and that equals an integer, right? This has to be converted to an integer, okay? And what that means is that this decimal points are just completely gone, right? This is the process called truncating. If we're going from something with decimal points to something without decimal points, the decimal points just get removed, completely gone. And that's how we get our value of 1 for this. An integer divided by an integer equals an integer. So the value of 1.5 goes from a double to that value of integer. And we truncate, meaning we take off the decimal points to get a value of 1. Now here, we do the correct way of casting, right? We change the value of one of these numbers in the expression, so in this case 3, to be type double. And since parentheses, it's higher up in the hierarchy than division, okay? So we cast the number 3 to a type double, and this gives us 3.0, okay? Because like I said, doubles are required to have decimal points. So 3 becomes 3.0, and then we divide that by 2. Now we have a double divided by an integer, and the return type of an expression where the types are not the same is always going to be equal to the one that has the higher memory or is higher in the hierarchy, right? So in this case, a double is higher in the hierarchy than an integer. So the value of this expression is going to be a double. And this outputs the value of 1.5 because now we have a double, meaning that we can store the decimal points in 3 divided by 2. So this is just another example of truncating here. We have a double 3.77 and we say become an integer, right? So all this does is it takes this 3.77 and it cuts off these decimal values, giving us an integer 3. And you see it's outputted right here. Now it's time for examples. Yay. Okay? So in this first one, we have a double 1 divided by 2. So since the double is in parentheses, we do that first. So we cast the value 1 to become 1.0. And now our expression looks like 1.0 divided by 2. So we have a double divided by an integer. And since a double is higher in the hierarchy than an integer, the value of this expression becomes double. So we do 1 divided by 2 equals 0.5. And since the value of that expression is a double, right, since the return type is going to be a double, then we can keep the decimal points, okay? Now in this example, we have a double 1.5 and we're going to cast it to an integer. So that means we just knock off the decimal places, right? The stuff before the 0. So we just knock that off, and our new expression is 1 divided by 2. We have an integer divided by an integer, and since they're the same type, the return type of this expression will be an integer. So integer divided by integer equals integer, okay? 1 divided by 2 equals 0.5. And since this is an integer, we have to truncate the decimal places. We don't have the capability to store decimal points, and this becomes a 0. As you'll see, it's outputted right here. This next example, we have something very interesting going on, okay? We are casting this expression right here to type double, okay? Now let me explain why this whole expression here gets casted to type double, as opposed to, this becomes a 1.0, and then this becomes a, 2.0, right? So let me just explain how this works. So casting is done after anything in parentheses, right? So you have a 1 divided by 2, that's an integer divided by an integer, and this gives us a value of 0 0.5. 1 divided by 2 is 0 0.5, and since it's an integer divided by an integer, the new return type of this expression has to be integer. So we delete this, we truncate the decimal places because it's an integer, and it becomes a 0, right? This is done. Then we move on to the casting, right? We don't cast both of these values here and then do the division, right? We do the division first and then we cast. That's just how it works when it comes to these decimal places, okay? So again, we are at 1 divided by 2, that's 0 0.5, and since this expression has to be of type int, we truncate the decimal places, and we're left with 0. Now we have to cast 0 to type double, meaning that we need to add decimal places, and the value of this expression just becomes 0 0.0. And you'll see that that's what it outputs right here. In this last example, we have an integer 3 divided by a 2, and the 2 is being casted to type double. Okay? So what happens first is the stuff in parentheses. The 2 gets cast type double. Okay? And now our equation is 3 divided by 2.0. So if you guys were working from left to right, you would see an integer goes first, and some of you might think, oh, well then the return type of this expression has to be integer. And that's just false, okay? When you have an integer divided by a double, it always equals the higher in the hierarchy, right? So this will be integer divided by double equals double, right? But even if this was like, short divided by long, or, ints divided by float, the higher in the hierarchy would always win, okay? So the double is what's going to take precedence over the integer, and this expression is going to be cast to type double. So we have 3 divided by 2.0, and since it's double, we can represent the 1.5 without having to truncate any of the decimal places. And you'll see 1.5 is here. Now for my folks coming from CSP, you might know what a string is, and I'm going to just say flat out, you can't do casting as a string like this when it comes to numbers, right? So you can't just say, oh, I want this number to become a string. It just doesn't work like that. In the next unit, you'll learn how to do this with a parse int method, but this gives you an error in compiling your code. It just does not work. So this is the end of our video for the day. Again, keep practicing. So to find examples of casting, all you have to do is a quick Google search for casting examples Java, right? That's all you need to search up, and you'll find some examples. But if you can't find any, or you just don't think that they're at our level, then contact me and I'll make up some for you guys.